And in fact, what we want to do is rekindle them. So what I've written here is to provide an alternative pathway through math for students who are not thriving in the existing STEM or AP pathways. So we're not trying to pull students out of the existing pathways. What we're trying to do is to create a new pathway. And in LAUSD, the TCMS class has as many students enrolled in it as does the pre-calculus class and the statistics class, the non-AP statistics. Those are the classes we think of as our peers, not the advanced ones. So we're looking at high school seniors, typically with SBAC level 2 or 3, preferably that have a C or better in Algebra 2, but who are unsure about what their fourth-year math course should be, and that plan or hope or dream about going to university. And sometimes this course can be what helps them sort of foster that dream. And the other point that I really want to bring home, because this is a question that a lot of your advisors will ask you, this course validates Algebra 2, which means two things. If a student got a D or an F in Algebra 2, but earns a C in the TCMS class, then they do not need to repeat Algebra 2 to be the UC or CSU eligible. So this class validates their Algebra 2 D or F, so they don't need to repeat it. Moreover, if they didn't even take it for some reason, suppose you have a student that didn't take Algebra 2, but somehow, maybe they had done something over the summer, somehow their advisor or their counselor, you call them counselor, put them in TCMS and they managed to get a C or better, then they also don't need to. So it can validate not only a poor grade in Algebra 2, it can actually validate the non-existence of Algebra 2. So what we're asking when you're teaching this class is that the student who gets a C or better has a chance of doing well in a college level class. That's the overview. That's what you're shooting for. So we're keeping students' quantitative skills vibrant. We're trying to kindle or rekindle the wonder of mathematics, and we're trying to fill the prerequisite holes while we're building the road ahead. That's what our goal is. But I think we need a little more specifics in order for you to feel comfortable and to see how the pedagogies that we use in the TCMS class fit that goal. So let me take a step back. There were two task forces, is that the plural of task forces? Task Force I, that ran recently. One was the General Education Task Force for the entire CSU system, so not CSUN, but the whole system. And they looked at what skills we would like a student to graduate with. What are the baccalaureate skills that we expect somebody coming out of? And they sort of came up with this graphic, which they were much maligned for, but anyway. So disciplinary perspective, so that's your major. Cross-cutting values, that's the ability to reason across different disciplines. Integrative experiences, those would be internships. And then inside of all of those were these essential skills. And what did they see as essential skills? Quantitative reasoning, written communication, oral communication, and critical thinking. And if you compare that to the WASC, which is our accreditation agency, and you have similarly an accreditation agency, or with another task force called the Quantitative Reasoning Task Force. This was K-12, Community College, CSU, and UC task force that I actually co-chaired that looked at what quantitative reasoning means. You see a consensus around what we expect students to know coming in. So there's this combination of quantitative ability and critical thinking and being able to communicate that in oral and written forms. So it's much broader than just, can you add fractions? But certainly, if you cannot add fractions, you're not going to be paying much attention to me when I'm teaching you the rich curriculum of TCMS. As you just saw, if we're going to be reasoning with quantities as delicate as we saw in the ProPublico, and we're freaking out when we're moving between fractions, decimals, and percents, we're not going to be able to get at the critical thinking. We're not going to be able to express ourselves orally or in written form on that topic if we can't attend to those critical thinking, those mathematical skills. So this is what the quantitative reasoning task force came up with, backing it up, saying, okay, if this is how we want students to leave the university, this post-secondary experience, then what do we want them to come in with? And I think these things will sound very familiar to you. So upon entering the California State University in pursuit of a baccalaureate degree, students will be prepared to develop their ability to reason quantitatively in a broad spectrum of courses involving quantitative reasoning that are offered within the CSU. In particular, a student who has satisfied the foundational quantitative reasoning requirement shall have demonstrated proficiency, oops, I need to go back, sorry about that, demonstrated proficiency and fluency, you can think mastery, in the combined skills found in the California State Standards for K-8, Algebra 1, and Integrated Math 1. What is there anything surprising about that statement for you? Anybody, you can just unmute yourself and jump in.
It's pretty low.
It's pretty low, right? It is not what there's no calculus there, right? There's no intermediate algebra. It's all about basically what people learn through 8th or 9th grade, right? In terms of skills. But what we mean by that is proficiency and fluency. Now, when does somebody get proficient and fluent in something? Do they get it when they take it the first time? Absolutely not. So in the process of finishing the K-12, so let's look at the next one. We want them to be practiced in the skills of the K-12 California State Standards in a variety of contexts that broaden and deepen or extend the K-8 Algebra 1 Integrated Math 1 skills. In other words, we are not backing away from the Common Core standards. What we're saying is the expectation coming out of those standards should be that they have broadened and deepened and made fluent the K9 curriculum, and they've expanded the context within which students have seen them. Now, for me, a typical TCMS student could be one for whom maybe some of those skills haven't been made fluent, or maybe they just don't see the relevance of what they've been doing, and so they haven't recognized it in a broader curriculum or a broader context. And so just sticking that student into a pre-calculus or a statistics class is going to further alienate them rather than pulling them closer into the fold. And so offering them this alternative that can deepen these skills is what we're sort of shooting for here. So if we look at, though, the other part, still part of foundational quantitative reasoning, again, this should be familiar to all of you. These are the 8 Common Core mathematical practices. So they should be able to make sense of problems and persevere in solving them. I think we just saw that, right? We were just doing the ProPublica exercise. That's an example of where students need to struggle and work together. They have to reason abstractly and quantitatively. They have to construct viable arguments and critique the reasoning of others. If you imagine if you had different people who had arranged that Venn diagram in different ways, how can you justify why one choice is better than the other or one choice is equivalent to the other? It's deliberately made that there are plenty of ways of filling in that chart that are viable. Model with mathematics. Clearly, that's what we were doing. We didn't get to the end of the exercise, but that's where we were going. Appropriate tools, use them strategically. Obviously, we do not want students sitting around dividing 4-digit numbers all the time. So they're going to be using calculators. Later, we'll be using spreadsheets. Attend to precision. So we talk about, do we round to 2 decimal places, significant digits? Look for and make use of structure, and look for and express regularity and repeated reasoning. So those are the things that this textbook, this Transition to College Mathematics and Statistics, is really good at. Really bringing home these Common Core mathematical practices, bringing them to life, getting students to work on them collaboratively within groups in a very dynamic and relevant way. It's a tough textbook, I'm not going to lie. That textbook really asks a lot of students and has very high expectations, which is one of the reasons why we've created a lot of supplementary material to help you and to help the students meet the textbook where it is, but also meet the faculty and the students where they are. So that's what we've spent a lot of time on. If you look at the first semester objectives for TCMS, really we're focusing on Unit 1, which is statistical thinking, and hoping to start Unit 2. So what that means is being able to read and interpret two-way frequency table and a bar graph, calculate different risks, absolute risk, relative risk, absolute risk reduction, interpret their meanings in context, be able to identify components of an experiment and determine if it's well designed, identify homogeneous groups by site and by calculation. Namely, they're going to be doing something which is typically pretty far into a statistics class. So those of you who've taught statistics before, when is it that you typically run into the chi-square statistic? Is it in chapter 1? Anybody ever teach chi-square in chapter 1? No, I'm not seeing any nods, right? This happens in lesson 3 of Unit 1 of the TCMS book. But it does so by doing a very narrow dive. It uses chi-square as an example of statistical thinking, rather than building up all of the statistical infrastructure on the way. Okay, so, and I can calculate chi-square and use it to see if two groups are independent. The independence, a lot of teachers skip, and that's perfectly fine with me. Let me pause for a second to see if there are any questions. Okay, so how does this relate to the foundational QR? So it's very clear that this TCMS book is going to hit the mathematical practices hard, and it's going to require that the students hone their arithmetic skills in Unit 1. Honestly, it's basically arithmetic. It's fractions, decimals, and percents, and then they're learning a new tool, which is some statistical analysis. So where are we going to fill in those gaps if they have the gaps? And that's where we use the ALEX program. So the ALEX program, for those of you who are not familiar with it, is a sort of artificial intelligence-based algorithm that is a graph of all the topics that you might imagine somebody might need for those skills, those K9 skills. And each node of that graph is a skill, and then the connector between the two nodes, so the edge between the nodes, is a weighted edge, which predicts the likelihood that if somebody knows this topic, they're ready to learn that topic. And using the fact that they've had hundreds of thousands, if not millions of students who have used this now, they're able to predictively guide a student through their quickest route to proficiency in the 176 topics that we've identified that students need to be fluent in order to survive when they get to college. I'm not saying that they're going to survive well if they're STEM majors, but honestly, we have plenty of STEM majors who start in college algebra, which is your equivalent of algebra 2. So just because somebody didn't take calculus in high school, or even didn't take pre-calculus in high school, does not mean that when they come to the Cal State system, they can't be a nurse. They can't be a kinesiologist, a physical therapist, an elementary school teacher, or even a physics major, a math major, a chemistry major. There's absolutely no reason why that can't be. So that's a really important message for you to share with your students, because a lot of times they think, oh, I'm never going to be a STEM major because I didn't take pre-calculus or calculus. That's absolutely not true. Most of our math majors and STEM majors in general are starting at least one semester, if not 2 semesters before calculus. So we'll take care of that if you can deliver us people who can do that K9 curriculum. So that's the thing we really need you to focus on. So the way we work is we have some intermediate objectives, and with the numbers and data done by about halfway through the fall, and then algebra part 1 by the end of the first semester. We have weekly time and topic goals, and we want demonstrated mastery of 100 of the 176 topics by the end of the first semester. By the end of the second semester, we want mastery in all 176 topics, and we can talk another time about how we measure that. Are there any sort of high-level questions on the ALEX? Anybody who's had a terrible experience with ALEX who wants to share or really query why on earth we would be using it? Because I think it's important to get that out there.
The issue we had with ALEX at our district, well, at our site, but I'm sure it happened district-wide, was that kids were having other kids do their ALEX for them.
Yeah. So this is Patricia, you're at El Monte as well, right?
Yes.
Hi, welcome. I'm sorry, I didn't see you earlier. So Patricia, yes, that's been a problem. The way we've dealt with it in the past is they do the ALEX in the classroom. So they spend 3 days, for most of this year, they spend 3 days a week working on the TCMS book curriculum and 2 days a week working on the ALEX in the classroom. And the final assessment is the final exam is a proctored ALEX assessment.
Oh.
Yeah.
Okay.
Now, in the COVID world, that becomes more complicated. I'm not going to lie. But our experience has been they actually have a harder time cheating with ALEX. When I say our experience, I'm talking about the Cal State Northridge experience. They have a harder time cheating with ALEX. You actually have to hire somebody to do your entire ALEX exam. Versus if I'm making up like a regular Algebra 2 exam, that stuff is on the internet so fast your head spins. In fact, most of the problems you can make up are already on Chegg. So, you know, whether you're using ALEX or something else, we have a problem. And so I would say I'm going to be working with your districts to try and figure out a way that we can, if we do end up online in the fall, that we can help students take responsibility for their learning and find environments within which they are encouraged to do well. But I will say equally that in many respects, ALEX saved a lot of the TCMS classes this spring, because students were able to continue to progress because they could use the ALEX. So they could log on with their teacher, they could ask their teacher questions, but they could keep making progress on this program, that at least they had that in hand. So thank you. Is it Patricia or Patty?
Either one.
No, Patricia's great.
Okay.
Actually, I should change my name. So I respond to Kate. But my grandmother would be horrified if I took my full name off. So I'm changing my name to Kate, just so if you call me something. And please do call me Kate. Don't call me Dr. Stevenson, for goodness sake. My children's friends call me Dr. Steve. I'm married to Pietro Perona, so you can call me Mrs. Perona if you want. But Kate is great. We're colleagues, we're peers. It's really important that we have an open channel of communication. So I want to make sure that everybody feels comfortable. Okay, so let's keep going. Patricia, did that help answer your question? Okay.
Yeah, thank you.
All right. So this started as a pilot in San Fernando High School. In fact, Bernie, I don't know if any of you saw him, who was on in the first session. He's been with us since 2014, and he still comes to these PDs. So go figure, how bad can they be? As I mentioned earlier, this course fulfills the UC CSU A through G requirements. It counts as an Area C elective. And so it gives them points towards being college ready. And it also serves as what's called a fourth-year math option for high schools beyond the Algebra 2 and geometry. And that's more of a CSU issue. So let me spend a little more time on that. So the CSU has this. So it's a joke, really, right? You can't read it. I can almost read it. It is the way that the CSU decides whether or not one of your, when they come to the CSU, is college ready, just in math. This is just the math page, okay? So let's blow up this little area right here. So what that area says is we're going to look at a whole ton of stuff that's related to your student. The old SAT, maybe we'll look at that. Oops, let me go back. We're going to look at the new SAT, the old SAT, and if they've done well enough on those SATs, we'll say, excellent, they're ready. They don't need any remediation, they don't need a co-requisite class, they don't need any help when they get to university, they're ready. Or they could do well enough on the SAT subject test in math, level 1 or level 2, or they could do well enough on the ACT, which is not super enormously well, right? 23 out of 36. Or they could do well on the SBAC. And then we have a few more ranges here for students. Now notice here, so if a student has completed a 12th grade course beyond Algebra 2 with a C or better, C minus or better, and they've done one of the following, then we'll also consider them college ready. A slightly lower threshold for the new SAT, a slightly lower threshold for the old SAT, the SBAC, the this, the that. But guess what? There's one other thing. So, well, not guess what. So basically, by taking TCMS, a student can be declared to be college ready with a slightly lower testing score. So in other words, if a student is a pretty good student, but just has issues with standardized testing, we're going to try and pick that up through the TCMS class. That means that your grade in the TCMS class really means something. And so it should mean something. Okay. So now going back over here, it turns out that there's also a difference between whether you're STEM or non-STEM. So if you're non-STEM, there are a certain bunch of thresholds versus if you're STEM. If anybody woke me up in the middle of the night, I wouldn't be able to tell you what these say. But just knowing that they exist is helpful. And you can see that there's a difference between people who have taken a 4th or a 5th year of class, so weighted GPA of 3.0 and a completion of a college level class versus if you don't have a 4th year math, you have to have a GPA of 3.7. That's for non-STEM, and then it's shifted up for STEM. Okay, do you see what I'm getting at here? Can anybody help me articulate what I'm trying to say? I see there's something in the chat. So I see in the chat, what information can be said for students who may be applying out of state to out of state colleges? There I have less information, but certainly this will count on their record as what's called an advanced math class. So for students who are applying out of state, it will be listed on their transcript as an advanced math class. Anybody want to take a shot at it? Why am I telling you this stuff about CSU placement policies?
You're trying to reduce the number of students who have to take remedial courses.
Well, we actually, look at this, I'm getting coffee delivered. We've gotten rid of remediation, so we don't have remedial courses anymore. What we have are supplemental courses. So if you take, say, statistics as a freshman, and you're not college ready, then you get to take an additional 1-unit course or even 2 additional 1-unit courses, one of which will be helping you with the statistics material and the other of which will be helping you with the prerequisite material. But yes, so I'm trying to reduce the number of students who need all of that assistance, because by and large, it doesn't work as well as students who come in ready. But I have another message to you. Any clue about what that message is? It's related to the first that you brought up. That was Renee? Mercy, yeah.
Yeah, for us to look at the importance of TCMS and taking it seriously to prepare the students to get into the level we want to get them to in college, whether the STEM program or not, that this can prepare them very well for their college, their higher careers. So if we are going into teaching it, we have to teach it with fidelity. We have to note the importance of it so that we'll prepare them.
Mercy, I could not have said that better. Thank you so much. That was exactly what I'm trying to get at. So not to, yes, and I see you're getting applause from some people. So I think that not in a kind of overbearing way, but in a way, not to think of this course as a dumping ground where the students are going to go because they're remedial and they're not good enough. That's not the mindset we want at all. We want to be optimistic and see this as a wonderful opportunity, but opportunity is a balance. So equity is a balance between access and opportunity. If we just let everybody in, then the opportunity that our baccalaureate degree can offer them is diminished because we're going to be spending all of our time on catch up, right? We only have 4 years. The clock starts. The state legislature has made it clear that they want people to graduate in 4 to 6 years. They're not going to pay for more. So if we're spending most of our time with them catching them up, we're not able to deliver them the opportunity that a bachelor's degree affords, right? And so the same thing with you, you're offering them this access to this course of TCMS, but we have to make sure that it's a valid opportunity, that it's really offering them the outcomes that are going to help them to succeed in university. So I just said again what Mercy said much better than me, so I don't even know why I repeated it. But thank you, Mercy. I appreciate that. It also makes me feel validated and listened to, which is nice. Okay, so let's go back to the TCMS class. This is an example of how you might weight your grade at the end of the semester or the end of the year. The ALEX percentage pie is just the percentage of the 176 topics in the ALEX course that the student has actually completed. And that counts for something like 30%. We give them 20% additionally for meeting their time and topic and objective goals. That's because we're trying to make sure, especially in that first semester, that they are making progress, that they're developing the right habits of mind, the right kinds of dispositions that are going to make them successful to overall complete the ALEX, but also make them successful students, that they're on target. So the first semester grade is much more focused on getting them on target. And then the ALEX percentage is of the 176, we expected them to learn 100 and maybe they only really learned 80. So they would get 80% would go into that 30% of their grade. But as long as they met all their time and topic and objectives, they have a buffer there. Then you see there's 2 categories called TCMS. So you see the TCMS quizzes and tests, and then you see TCMS classwork and homework. And here you can have a lot of flexibility. If you want to put a little more, if you're being very careful about grading their coursework and that group work, and you're really being assiduous at it, you can put more weight into the classwork and the homework category and a little less into the testing category, especially if we're in the online format. So it may be better to replace some of the tests or some of the tests and quizzes by group projects, by presentations. So here you have a lot of flexibility. The only thing that I ask is that it adds up to be, this adds up to 110%, doesn't it? Nice, nice, I can add. Okay, so basically this college readiness assessment, what I was going to say is you can actually ignore it. The college readiness assessment is a repeat of what the ALEX does. So either you put 50% into the ALEX and you just don't do the college readiness assessments, which are an element that's provided by the textbook, but it's purely skills-based, so it's just a repeat of the ALEX stuff. So I'll correct the slide and I'll put it in the Schoology box. But basically what we want is 50% of the grade is going to come out of the rich, mathematical practices as textbook, and 50% of the grade is going to come out of the ALEX skills in that first semester. Does that make sense? And again, to Patricia's point, the ALEX percent grade is based on a proctored comprehensive knowledge check. So for those of you who've used ALEX before, there's two different tests that ALEX gives. One is an in-progress one, which only tests the material that they've been working on recently. And then there's a comprehensive one, which tests the full range of the course that you've selected. And so this would be a proctored test administered in December in which they actually have to demonstrate their mastery. Okay. And so we have a way of deciding whether or not a student gets a different grade. Again, you have some flexibility here depending on how much emphasis you put, but here's a sample. So you might get an A if you completed at least 70 of the topics in ALEX, you demonstrated mastery in 5 of the TCMS content topics with at least proficiency in the remaining TCMS content topics, and then all the way down to you're failing if you completed less than 26 topics in ALEX, or you demonstrated proficiency in at most 1 of the TCMS topics, and then we have sort of everything in between. Okay, so this is sort of something between a mastery grading rubric. I mean, ALEX is by its definition a mastery grading tool, so you get many opportunities. I strongly recommend that you give people the opportunity to demonstrate their proficiency on ALEX early. If you have a student who's ahead, you can schedule a comprehensive assessment before the final exam and just have that be their final exam. They've already done it. That's great. That's a big motivator for students, right? So as soon as they cross that hurdle, that's great. For the TCMS material, I encourage you to take a mastery learning perspective, giving people multiple opportunities to quiz and to test and to demonstrate their mastery of the topics rather than just moving on from one topic to the next. Okay. So required for new teachers. So the TCMS part, you're going to learn to work with, they're going to learn to work with their peers in interactive group settings. So almost all of your classroom work with students on TCMS textbook material is going to be in group work. You're going to build on their strengths and fill their weaknesses to create authentic competence. And you're going to explore mathematical principles through real world examples to connect to their purpose. And in some cases, those real world examples are coming from the textbook, which is from 2014. So it's sort of real world. Or there are things that we're bringing in, like the coronavirus, the ProPublica, the stuff that we provide you with or that you come up with and share. So the first thing for them to notice is that this is a different kind of math class. It's not just the, here's topic, here we're factoring polynomials where they're degree 2 and there's no, and the coefficient of x squared is 1, right? And now I'm going to give you a bunch of word problems in which miraculously they are problems that involve factoring quadratics where the coefficient of x squared is 1. Instead, it's going to be very tricky for them. And in fact, what you're going to see in Unit 1, these are questions when I've done professional developments with math professors. They have a hard time. Human beings are not very good at these two-way tables. Probabilities are not natural for humans. And so it's nice for them to realize, and if you struggle in class ever, just take this perspective. It's nice for them to realize that this is transition to college level math and statistics. And it's college level because of the reasoning that you're doing. The actual reasoning is complicated and difficult for grown-ups to do. And so if every once in a while it's difficult for you to do, that's okay, because we get tangled up in these ideas all the time. Okay, so this is where the class actually starts. So comparing risks. So this is the very first example in the very first lesson. So the book is broken down into units. Unit 1 is statistical thinking. Unit 2 is algebraic thinking. Unit 3 is counting, and Unit 4 is financial mathematics. Everybody who teaches TCMS does Unit 1 and 2. And then from there, you can choose whether you want to do Units 3 and 4 Or do you want to go on to one of the other 4 units? There's another one on statistics. There's one on apportionment, which would certainly be very important right now. We have a whole bunch of resources available around gerrymandering. So there's a lot that can be done in that space. But the important thing in terms of getting the students college ready is for them to re-experience the mathematics that they've learned up till now in this more mature context. So this very first problem says some teens engage in risky behavior. About 6,748,000 high school boys in the United States do not smoke cigarettes, while 1,645,000 do. The table below shows how many of those smokers and non-smokers can be expected to get lung cancer if the smokers continue to smoke based on Canadian data. And so then they give a reference, and you can see this is from 2011, which now your students will think is ancient history, but at the time the book was written, that was news. And so then there are some questions around, and just to point out how hard this is, in my opinion, the editors of the book, the writers of the book, messed up the first questions on this. And the answer to the answers that are in the teacher's edition are to the question that they meant to ask, whereas the question doesn't ask what they meant to ask. So now what I'd like to ask you to do is to pull up or print out or do what you need to do to get the handout for comparing risk, the think about this situation. So let me pull that up for you so you can see what I'm looking at. So hold on one sec while I look for that. Just so you'll see what I'm talking about. So TCMS, Unit 1, Lesson 1, comparing risk, and it looks like this, but without the highlighting. So take a second to pull up that document, because you're going to be working on that now in your groups, but we'll get started off together. Oh, okay, I'll come back to this later. Okay. So this is the paragraph that we just read, right? Okay, so if I were going to look at this, so why don't you just take a second to highlight on your own, just highlight the part of the table that's related to boys who smoke and think about the answer to what proportion of the boys who smoke get cancer. Just think about what kind of mathematics you're going to do that. And then once you've done that, maybe also fill in this chart here. And Ottilia, can you just double check that the other Jamboard is shareable and writable?
It's all good, Kate.
Great, thank you. Can you share the link to the Jamboard in the chat? So I'm going to stop sharing that screen and I'm going to go back to sharing my, my iPad. So now I'm sharing the Jamboard for this. So this part we're going to do is a whole group discussion. So what you notice right over here I have filled in smokes and get cancer. What error am I avoiding them making? Just go ahead and unmute yourself and jump in if you have something to say.
Same thing as the last Venn diagram, coming up with a Venn diagram that is missing the middle, the intersection.
Exactly. So what I was careful to do was I took one of these, I took from one of my criteria, right? And the other one I carefully took from the other criteria, right? So that I ended up, oops, gets lung cancer, so that I ended up with a rich intersection in between, right? So I end up with something in here that actually is meaningful, right? So there's something in here that's meaningful. So if I were to fill in that yellow, what would I write in there? What would I put in this little box right here? What number would go there?
283,000.
283,000, because these are the folks that get cancer and smoke, right? Get cancer and smoke, get cancer and smoke goes into that intersection. So if I were teaching this class, it would sort of depend on what my experience has been with the students. If you've done the week 1 curriculum in which they've already played with Venn diagrams quite a bit, which Peter will introduce you to a little bit later, you might decide that it would be a good idea for your students to struggle with this a little bit. So you wouldn't give them the smokes and gets cancer, you might let them struggle with that a little bit. But since I knew that we would have already done that exercise, I decided just to let that go and jump straight in. So that's up to you whether you want to, so you could consider eliminating the labels and letting them productively struggle on that, if you think that that's something good for your students to do. And the Word documents and the Google Docs are all available through Schoology. So any supplement that I have for you, you can also access through the Schoology group. Okay, so how about the actual exercise? Any thoughts on that? So the first exercise asks you a really broad question, and our experience is that the students don't do so well, to put it politely. Let me just move that back up because it got shifted somehow. Don't do so well when you ask them that broad a question. Now, it still might be worth asking them the question and having them think about it, but if you want them to actually make progress on it, what we did was we took these questions that are in the textbook, A through, I think it's G, and what we did was we scaffolded them a little bit, okay? So instead of just asking, is a smoker or a non-smoker more likely to get cancer? If a student is used to doing this kind of thinking, they're gonna know what they need to do. But on the other hand, what we ask them to do is highlight the part of the table related to boys who smoke. So what part of the table am I highlighting then? Am I highlighting a row or a column?
Column.
I'm highlighting a column because I'm focusing on boys who smoke. So I'm right here, right? Boys who smoke, okay? What proportion of boys who smoke get cancer? What am I looking at when I'm looking at people who get cancer? Am I looking at a row or a column?
Row.
Row. Who's my outstanding participator there? Hang on, because I can only see a few of you. Is that, what's your first name, Ms. Rodriguez?
Jacqueline.
Jacqueline, hi, nice to meet you.
As well.
Or nice to see
Yes.
you. Okay, Jacqueline. So I'm gonna highlight now this row here. And so now we see again that 283 very clearly. So spending some time with them and letting them see the relationship between the two different representations and have them argue back and forth can be really helpful. Now, my 180-year-old neighbor is about to ring the doorbell, which is gonna cause my dog to start barking. So we're all just gonna live with that, okay? And hopefully somebody else will answer the door. There, see? Hello, people. Oh, there's somebody coming. It's a miracle. Okay. The dog will stop in a second. There. Okay. So, right. So now we're in a better position to say what proportion of boys who smoke get cancer. So what other number am I going to need from this chart in order to figure out part 2?
The total?
Which total though?
Total of smokers.
Smokers. So that's the 1 million, right? So that's this guy right here. Do we agree?
Yes.
Yeah, okay. So actually what I meant to do was this, right? We need this number. And so probably because you're all math teachers, you got this right away. You said, well, it should be 283,000 divided by 1,645,000. And what did you get?
17%.
So can you give me it first as a decimal? So 17, what else did you get? 17.
2036.
2036. So in general, a good rule of thumb for TCMS is typically we have something like 4 significant digits in the numbers that we've been given, roughly. And so what we're going to do is we're going to, so this was an approximation anyway, we're going to further approximate it to 0.1720. And then we're going to say that that's 17, except I can't write, that's 17.2%. Okay? So that's one of the first lessons, because you'll see if we round it to 17% and then we round the other one, we're going to get completely different answers down the road a little bit. So we have, the good rule of thumb is not to lose too many significant digits. So let's keep it around 4 significant digits. And then when we write a decimal, we typically round to 2 decimal places. But since the second decimal place was 0, I didn't write it down. Okay? So there you see, I don't know about your students, but even my students, if I just handed them the question, is a smoker or a non-smoker more likely to get cancer? That's a great thing to do and let them chew on. But what are they going to do when you ask them to do that?
Stare at each other.
Exactly. And that is exactly what they did. The first few years I was helping work on this course, just the feedback, and Alan's been here for a long time, so Alan can attest that they will just stare at that problem and just not know where to get off the ground. So even with this scaffolding, you'll find that they don't necessarily think of this total here. They may fill in the total over here and divide 283,000 by whatever the total over here is. There's lots of different numbers for them to choose to put in the numerator and denominator, and you will probably manage to find one person who manages to put every possible one in every possible spot. So that's why we added a little bit of the scaffolding, but it still gives them some rationality. What do you think is still the most common error that they make even after highlighting this row? That's the mailman, by the way. That this is, mailman's usually faster. Nellie, leave it. Oh, somebody else has got a dog. Thank you for that. Okay, what do you think is the other mistake that they make all the time with this? Hush. Here, while you're thinking of that, you can see the offender. Say hi, Nellie. There you go. Yeah. Hush. Shh. Leave it. Any thoughts? No?
Thinking that maybe if they ended up taking the 283,000 and compared it with the 1,000,000.
Yeah. I mean, it's not stupid. It's not a stupid thing to do, right? It's like the comparison, right, between the two groups. It's not a crazy thing to do, right? What do you get when you divide those two numbers? So if I take 283 and I divide it by 11 million, 1 million, etc. Can anybody do that? for me?
600. Which one?
283,000 divided by 131362000. What'd you get?
0.277 or 78.
7. Let's do 78. Okay. Or 7. What did you get? 7777.
0.20778.
Okay. Okay. So let's hold on to that one. Maybe it'll be interesting. Maybe not. Okay. So now I'm going to go to my next Jamboard. So you see how this is a little nicer to use because I can write on it. Let me just show you what I could be alternatively doing. So if I go back to sharing my, my sort of flat slides, then what I can do is I can say, oh, look, here's the answer, right? But that's somewhat less beautiful, and plus it's really hard for me to draw on these guys here, right? So the Jamboard gives me a slightly more interactive way. You can also use the Zoom. There's a whiteboard in the Zoom, but it's harder to pull things in. So if you've done the Jamboard ahead of time, you actually have that resource. You can write right on it, even if you don't have them share in groups. Okay, but I've highlighted the column and I've got the answer there. But it kind of, what I object to in this style, if you have to teach online, is it pops out exactly like the miracle that students think math is. It's like, boom, there's the answer. It came out, it fell from the sky and straight onto my PowerPoint slides, my Google slides. So now we're going to move to the next set of questions. So if you're following along with your handout, you'll see that what we've done is parts 1 and 2 of question A. And so now we're going to try to highlight, now we're going to try and get a little closer to, is a smoker or a non-smoker more likely to get cancer? What we've done so far is what % of the smokers get cancer? So guess what we do here? We do what % of the non-smokers get cancer. So go ahead and take a second to fill that in and let me know what you get. And then see if you can answer this question A, is a smoker or a non-smoker more likely to get cancer? And I'm going to ask somebody to explain their reasoning. So I'll give you about a couple minutes.
Would you be able to show the table again?
Oh, sure. I'm sorry. Yeah, let me go back. There's the table, but now you can't see the questions, but you have the questions. So yeah, I'll leave the table up.
Thank
Yeah,
you.
sure. Oh, wait, I have a way of doing it. Let me go back to sharing my, I have them both on one thing. So let me go back there. So I'm going to stop sharing for a second and then you'll see both in the same space. There you go. Now they're both there. Okay, if you're done already, you can continue doing B, C, D, and E while you're waiting for everybody else. If you're already done with that, you can just look at me and then I'll know how many people are. Of course, most of you don't have your camera on, so that won't tell me anything, but that's okay. Just because you don't want me to see your rats running across your curtain rods. Okay, so let's come back together. Obviously, if you were students, maybe I would wait a little bit longer. But I've highlighted the part of the table that's related to boys who don't smoke. So hopefully we're in agreement over that. We're looking at the proportion or percent of boys who don't smoke but get cancer. So what row am I interested in? Yeah, the cancer row, right? So it's still the same row. I've just shifted columns, which is something that's tricky for the students to quite get their minds around. And so now the ratio that I'm interested in is going to be which one?
88/6748.
Great. So that is going to be 88,000 over 6748000, which Alan correctly says I don't care about the zeros. And what did you guys get for that?
101.
101?
1013.
0.013.
013.
Okay. For some reason, my decimal place isn't working, but let me try again. Doesn't want to do a dot there. There we go. Okay, so that would be as a percent, that's going to be what?
That is the percent.
That's the percent?
Oh, no. That's not.
I don't know. I mean, it's a question. It's an honest question. I don't remember off the top of my head. No, what I got, that's the actual ratio. What's the percent?
1.3.
So it's, in fact, let me get rid of that equal sign and I'll just put it next to, so it's 1.30%. Okay. So now can we ask the question, is a smoker or a non-smoker more likely to get lung cancer?
Smoker.
A smoker. Great. And what's your justification?
Look at the numbers right here.
Exactly. So I've got the quantitative reasoning to back it up, right? So Captain, can you bring it home for me? Give me a sentence.
Oh, I didn't know I was on.
Well.
The dog and I were talking.
All right, go for it. Captain Smith.
Where's that page? Hold on.
I'm on number 5.
Number 5.
So can you answer, or somebody else, because I caught Captain Smith off guard. Can you answer the question, is a smoker or a non-smoker more likely to get cancer? And we're going to justify our answer using our quantitative reasoning.
Because we have we got 20%, right?
For
20% are the ones who get cancer.
okay, so we know
Yeah.
that it was 17.2% of smokers get cancer.
Non-smoker.
And then what?
1.3% don't.
But only 1.3% of what get what?
Of non-smokers get cancer.
Great. Smokers get cancer. Thus, a smoker
Is more likely to get cancer.
is more likely to get cancer. So hopefully you can see that on your screen. And if Otilia put the link to the Jamboard, you should be able to see it also on your version of the Jamboard. So that way you could I could ask, hey, can somebody highlight for me the column that's relevant for our discussion? Can somebody else highlight the row relevant to our discussion so you can get back and forth? I could even ask a student to write that out, right? So there's lots of different ways, if you have a small enough group, obviously, that you can interact with this Jamboard in ways that are a little more like a classroom experience. The other thing I was going to say is now I'm talking to you as a post-secondary instructor, and I think Ottilia might be able to back me up on this. This process of writing that sentence out is really important to us. So not just getting 1.3% and 17.2%, but the fact that they're able to put it into a structured sentence that addresses the question and brings those calculations back in and uses it to make a statement is a really important skill for them when they get to the college level. So that is something that we definitely want to be sure that you're focusing on. So question B is sort of more of a reflection. So remember why each part of the quantity was related to which question. So I don't think we need to do that. So on part C, did anybody do this? So complete this sentence. A male smoker is blank times as likely to get lung cancer as a non-male smoker. So first of all, can anybody tell me what math they did to do that? To address that question, what kind of mathematics did you look at?
They divided the 0.172 by 0.013.
172, so 0.172 divided by 0.013. And what did you get?
I get about 13.23.
Okay, great. Did anybody do it differently? So let me draw your attention. If we had rounded this to, suppose we had rounded our first answer to 17, right? Percent. And we had, what would you have rounded your second answer to? This one right here. What would we have rounded that to if we weren't paying attention to those significant digits?
1%.
Exactly. So if we had taken 17 on the percent on the top and 1% on the bottom, we would get a very different answer here, right?
Yes.
And so, you know, you may want to let that happen, right? And then you could ask the students, which is a more accurate answer? Is it a male smoker is approximately 13 times more likely? Or is it that a smoker is 17 times more likely? Which is a more accurate answer? And get them to think about that. Because I think that these data were chosen on purpose to bring that definition, that difference out. So if we were going to answer this, I think that we would agree that the 13 is a much closer approximation to how many times more likely a smoker is to get cancer versus a non-smoker. Does that make sense? Okay. And so then here's an interesting question that actually has almost caused fist fights in prior PDs for this course. So the question used to say, how many cases of lung cancer could be prevented if boys did not smoke?
If none of these boys smoked.
If none of these boys smoked. Whereas now what I've said is how many could be prevented if the boys who did smoke, had not smoked. Because people took completely different pathways on this. Both of which were legitimate. And I think that that's really cool. Like you could leave it within the original question because some people said, well, if I look at how many could be prevented if nobody smoked, then I could just reconsider everybody together versus what the question is trying to get at is just how many of the smokers, if they didn't smoke, would still die of cancer, but it would be less than if they did smoke. And so you look at that comparison. Does that make sense? And so I don't know whether you want to leave that ambiguity there and let the students struggle, which was a lot of fun to watch the teachers struggle, and people got angry. I don't know, Alan, if you remember, but last year, like people got really hot under the collar over this, the different interpretations. So, which is good in a way, but I did decide to try and clarify it there. So what kind of computation would we do here in part D in order to get of how many cases of cancer could be prevented if the boys who did smoke had not smoked?
Well, I usually started off by saying that even if they did not smoke, there's a percentage that gets lung cancer.
Mm-hmm.
So which is just inevitable that, yeah, that proportion of this population will always get lung cancer even if they do not smoke.
Okay, can I stop you there, Alan? So does everybody hear what Alan's saying? He's saying even if you don't smoke, you still got a risk of getting cancer. Do we know what that risk is? Can somebody tell me? What's that risk factor? Yeah, Gregory?
It's 1.3%. That's the percent of non-smokers who got
Right.
cancer.
Right, so we would expect, coming back, go on, Alan, we expect 1.3%
of the non-smoke of the population.
Of the, okay, of the formerly smoker, now newly non-smoker, right?
Yes.
Of the
1,645,000.
1,645,000.
Yes.
So are these were the smokers who now don't smoke, who
yes.
we suppose.
So that gives you how much would have got cancer from the smokers, even if they did not smoke.
Mm-hmm. So we expect 1.3% of those to still get cancer.
Yes.
And can anybody tell me what that number would be?
I think it's about 21,000.
I think somebody's computed it. Go ahead.
Yeah, 21,385.
So that's 21,385.
Yes.
Yes.
Oops. Okay. So that's 21,385 we expect to get cancer. And now can we answer the question, how many cases of lung cancer would be prevented?
So we subtract that from the 283,000. 83 minus 2.
Which is?
261,615.
Great. Okay. Is that how you would do it with your class? With Alan and Greg carrying all the weight? But what would be great, suppose we did it as we did this, right? So suppose we did this as a whole class discussion right up to part D, right? Part D, what does part D allow? If we break them off into groups now and we bounce into those groups via our breakout rooms, what are those students going to be doing then? Maybe Che or Elizabeth or Alyssa.
Let's see the smoking.
Patricia.
Information in the table.
They'll probably be working together.
They have a shot, right?
Yeah. They'll probably try it.
And haven't we already given them some of the pieces, right?
Yeah.
So we've given them some of the pieces, and what we're testing them on in a formative sense is whether they're able not just to repeat the calculations that we did, but to use the calculations that we did to interpret another situation, right? So we're not just doing 1,000 examples and then asking them to regurgitate back, we're asking them to act on it. So this could be a very meaty exercise for a bunch of high school kids to struggle with productively and try and figure out what of the information, what piece of the table are we looking at, what piece of the computations that we've already done. So you might want to do a little bit of scaffolding ahead of time to sort of tell them what pieces they should look for without telling them where those pieces are in the table or in the computations, but to give them some courage to say, everything you need to answer this question is either in the table or we have already deduced from the table, and then let them go off and do that work. I have always found this to be one of the best groups group work that we in our professional developments. In general, we are all together, and that's much easier to do. When you're teaching your class, you can spend 3 class periods on this. So we're not expecting you to do this in an hour or whatever I did. I think I did 45 minutes. Instead, we expect you to spend several class periods on this exercise. So I'm going to leave it there because I want to be respectful of your time. So I would just remind you that you have homework to do, and it is on your agenda, and it is inside of that Schoology course. So if you need help with that, Otilia and I will stay on for a little bit to get you guys all oriented on that. But otherwise, if you're all set to go, you're more than welcome to enjoy the rest of your day. We will see you on Thursday at 9 a.m. with the same link. And then we will break out immediately into breakout sessions. I thank you for your patience while we fumble along through this brave new world of online PD and forbearance. And I look forward to seeing you all on Thursday at 9 a.m. sharp. Don't forget to do your homework though. So if you're a little unsure, thank you, Juan. If you're a little unsure about what to do for your homework, you can stick around and I'll walk you through that.
No,
I'll just pause
sure.
for a second.
Just so is it a 3 hours or 6 hours? Why is it asynchronous and not, because synchronous is already 3 hours?
In order to pay you for 2 PD days, they have to be 6 hours long.
Okay, so we are paid for this session, not the homework.
So in order to pay you for a day, for this to be a full PD day, we had to do a full 6 hours. And I thought if we did 6 hours on Zoom, we would all die. In particular, I would die. I actually now realize I have so much adrenaline, I could probably keep going for a while. And I wish I had more time to run through more of these exercises with all of you, but I think you've gotten the idea of what we're after. And we have lots of time on Thursday to continue the story, the discussion as new teachers. But the rest of the PD that you do with me will be much less overview and much more literally working through the content either of the book or the supplemental materials that we've developed for the book.
Hi, Kate. I don't have book. Do I need it for the assignment?
No, you should be fine on the assignment without the book.
So how about on Thursday?
On Thursday, it would be good if you had the book. So what I'll do is I'll send out an email. I will put the textbook pages that I think you need into the PD course on Schoology.
Thank you.
All right, you're welcome. Thank you.
So how do we get the books?
Can you say who you are?
Mercy.
Oh, hi, Mercy.
My hand is up.
I see you now, yes. So you're, remind me which district you're at, Mercy? Are you at LAUSD?
Yes, I am.
Okay, so then you should be getting your textbook through LAUSD, and typically I've been able to get people their textbook ahead of time. Okay. So I will, what I think I'll do is maybe I will send out an email to all of you and just ask who it is who doesn't have a hard copy of the textbook yet, and I'll try and get your districts to get them to you.
Sure.
Okay.
Thank you. Thank
you.
So
just be sure to respond to that email so that I get so that I'm sending them specific list of names of people. That would be helpful. Rather than trying to do it now, I think it's going to be confusing.
Thank you.
You're welcome. Thank you for your participation, Mercy. I really appreciate it.
I think they also want us to go to sign out on the...
Oh, God, yes. You're supposed to sign out on that Google Doc.
I was trying to find out, somebody asked if it was 3 or 12. So, yeah, fill out that form again, put 12 o'clock.
Yeah, put 12 o'clock because they know that it's the rest of it's asynchronous. They're expecting that.
Yeah.
So if you're signing out now, be sure to sign out on that Google Doc, and maybe Otilia, we can send them the Google Doc because some people left and we didn't tell them that they needed to come back because they didn't. So we'll just send out that Google Doc link and make sure people sign out saying that they left it.
It's on the chat as well right now.
Okay, great. Thank you. Thank you very much. So that Google Doc is in the chat right now. So if you want to sign out right now, that's perfect.
We cannot click it.
You can't click it? Yeah, it looks like,
it's like, yeah.
Yeah, it's that long one. So let's try it again. So look at Otilia's. Is that one working? Yeah, not the one from Ottilia, not the one from Carmen. Somehow the one from Carmen was the super long one.
Yeah, it's the latest.
It doesn't matter which one we do, right?
It doesn't matter which one we do. It's just that the link doesn't work for some people. The long link doesn't work for some people. So I think the most important thing is that everybody knows that they have homework and that they know where to find it. So how about I focus on that for a minute? Yeah. So let me stop sharing here and start sharing on my Schoology. So let me just pull that up for a second. Peter, how did you do?
Very well.
Yeah, your Alex link worked? Hallelujah.
My Zoom link worked.
Oh, sorry, your Zoom link. That's what I meant. I meant that.
Worked. And now you've got me, my day's activity is to learn Jamboard.
Woohoo! Okay, so
because as I was doing the thing, it's so suited to what.
Yeah, right? I mean, Jamboard is perfect for that.
Because you can't go to the whiteboard in Zoom and save it.
That's true. There is a really complicated way of doing that, but it stinks. Yeah. And it saves it to some random place deep inside of your computer, which you may not be able to find.
Thank you so much for the presentation, Kate.
It was great to meet you, Jacqueline, or to see you again.
Yes, but, hopefully see you Thursday.
Yes, I'm looking forward to it. So now what I'm going to take care of, everybody. So I'm going to share my screen so that we can look at the Schoology together. So just so we're clear on what you're going to be trying to get done between now and next time. So basically, if you are new to TCMS, you are going to do this supplement A. So if I click on that, it will eventually open up an exercise. My internet is getting tired. So you'll see there's supplement A, discrimination. It's a document right here. So that opens up a PDF document, which also will have a link to a video. So let me open up that document, and hopefully the video link is there. Waiting. Oh, that's a Google Doc. Oh, interesting. Hang on. Let me go back. Sorry about that. Oh, sorry, that's the spreadsheet. Yes, this is the PDF. It even says PDF, and that also says Google Doc. So then you get the handout for this exercise. So you can click on that and open it up eventually. Come on, you can open. Here it comes. So here we have a little exercise that Ann Watkins developed to try and get people to think about what is meant by modeling a situation by chance. So here we have a company, and they have laid off a bunch of employees. And of the employees, they've got, so consider the data below on 14 hourly workers that were laid off by Westvaco. Each was categorized into one of two groups, under 40 or over 40. So here were the age under 40, and here were the over 40, and you see the circled ones are the ones that were laid off. And so the question that you're trying to investigate, or that you would investigate with your students, but I'm asking you to act as the students this time, is whether there is evidence that the Westvaco Corporation has engaged in age discrimination. And the way that we get at that is by trying to figure out whether having how many, 1, 2, 3, 4, 5, 6, 7 of the 10 people being over age 40 could have happened by chance rather than by a deliberate act. So that's really the only exercise here. So what we're trying to do is, how do we take a specific instance of an action by a company and compare that specific instance to a random event? Well, the way we go about it is on the second page. I'm going to ask you to actually do this, third page, sorry. Here are all the ages of the employees. You're going to cut out the ages and shuffle them and randomly select. And you're going to do it over and over again. Do it maybe 3, 4 times, and you're going to get a histogram. on that histogram, you're going to be able to answer whether or not you think this could have happened by chance. And what we'll start with next time is we'll pull all of your material together, and we'll be able to make a histogram from all of our iterations of doing this exercise. And so what I'm asking you to do, besides just answering the questions and filling in your answers to this, you're going to upload this sheet. But in addition to doing that, I'd like you to put your histogram into this Google Sheet that's linked to the exercise so that we can pull all the data in together. So we can make one histogram for all of us. So that's that first exercise. So hopefully you have everything you need. And to go with that exercise, there's actually a video link, which I realize I didn't put in, but I'll put it in just when I get offline. There's a little video that goes along with it that can help guide you. So that's if you're a new teacher. Any questions on that exercise? And the way you're going to answer it is if you're a student, when you log into this exercise, there's going to be you click on the exercise, there'll be a little upload, and you're going to upload a screenshot of your answer sheet, and you're going to fill in your Google Doc. All right? Then everybody is going to do the coronavirus exercise. So here's the PDF to the coronavirus, and there's a video that goes along with it. The video is embedded, the video link is embedded in the PDF. So let me just pull that up. So here we have the exercise and the video, if you wish to watch it, and I'll put the link also in the exercise. I realize I didn't do that here, but the video link is on, it's way down. I'll put the video link up front because it's probably more fun for you to watch the video ahead of time. What happened was this guy, Dave Kung, is a friend of mine. He made up this beautiful video for modeling coronavirus. And when I watched it, I thought it was brilliant, but it needed so much scaffolding so that even, so that I could understand it, that I created this handout for that. And then I decided to share it with the TCMS group. And it's a beautiful glimpse of what we're trying to achieve in chapter 2, in unit 2 of the textbook. So that's the second exercise. And again, you're just going to take, you can take a picture with your phone and just upload those images as PDFs into the site. And then let me go back to and then you'll see there's one other exercise here, Squaretopia, which should be pretty quick. And again, there's a video that goes with it. So here, this one, you're going to try and do some gerrymandering. So you're going to imagine that you're in a world in which there are 90 different precincts, and they're going to be divided into districts, and you're going to try and divide them up in different ways. One, that they're compact, another that they're proportional, and then you're going to try and gerrymander it so that the shaded region wins, and then you're going to try and gerrymander it so that the unshaded region wins. And again, there's a video to guide your investigation of that. So before you start feeling too desperate, let me stop sharing and show you where all of that is in one place. So let me go to my desktop, share. Inside of your agenda for today, let me go and find the agenda, assuming I can find the agenda. There it is. Inside of your, oh, is this it? No. Where's my agenda? Bother. Ah, there it is. It was right next door to where I was. Okay, so inside of your agenda for today, you see the asynchronous feedback. So all participants, you watch this video and you do this handout, which was what I just showed you. If you're a new teacher, watch the age discrimination video and do the handout that I just showed you. And then you're going to do the Squaretopia. So this is all the stuff for the new teachers with the links, and this is all the stuff for the returning teachers. So if you're a returning teacher, you're only going to do the coronavirus and the gerrymandering. you have more stuff to watch on the gerrymandering than the new teachers do. The new teachers just watch my quick this is a 7-minute video on gerrymandering, and then you do the exercise and that's it. So they're designed to take you 3 hours. Don't spend more than 3 hours on them unless you're having a really good time. But in order for this to count as a full day of PD, we needed to fill it out that way. Okay. Any questions on that? Any concerns? Have fun with it. All 3 of those videos,
When do you say it's due?
It's due before we start the next PD. So if you could get it, so definitely the supplement A, the one on job discrimination, I'm going to use your data. So if you could get that one done by Wednesday night, that would be great. Otherwise, the rest is due just before we start our PD on Thursday.
So today's going to be counted as a 3 hours PD or a 6 hours PD?
6 hours PD if you do the asynchronous as well.
If you do the asynchronous. So, but when we're signing out from that, we should.
You only sign out for 3 hours. That sign out is only for the synchronous part.
Okay.
So where do we sign out?
That was the Google link, which should be still in the chat. So let me look at the chat again.
Yeah, it's right there.
Yeah. Thank you, Mercy. So if we can put it in you want to put it in the chat one more time so that it's at the bottom, Otilia?
Okay.
So they don't have to scroll.
On Carmen, Pastor John.
Any other questions?
Yeah, the other one is I'm going to wait for the Schoology after.
Right. Anybody else need help with Schoology?
I need help. This is Juan.
Hi, Juan.
I was trying it during the break and I couldn't do it. I don't know what went wrong.
And remind me, Juan, you're at LAUSD, right? Juan, you're muted. Yeah.
Yes, yes.
You're at LAUSD. So that is more perplexing for me. I have more. I'm much more optimistic about helping the Compton people because they shouldn't be able to get in. I have no idea why you can't get in, but I am going to take in with you for Juan. What I'm going to do is I'm going to write to the Schoology guru at LAUSD and ask why you're having trouble. Is anybody else from LAUSD having